Hello students. So today I am going to discuss you with the nomenclature of organic compounds. It means IUPAC system of nomenclature. As you know, IUPAC stands for International Union of Pure and Applied Chemistry. So today I am taking the example of nomenclature of hydrocarbons, and again I am going to select the aliphatic open chain hydrocarbons. Aliphatic open chain hydrocarbons. So aliphatic open chain hydrocarbons are of three types. One is alkane, alkene, and alkyne. All the three names of the hydrocarbons have a common group of letters, that is alk. All the three hydrocarbons alkane have a common group of letters, that is alk, and alk is suffixed with ane, ene, and ine. Ane, ene, and ine. Ane, you will found all the single bond in alkanes. In alkenes you will find at least one double bond, and in alkyne you will find at least one triple bond. One triple bond between carbon atoms. In alkane all the bonds will be single bond, and in alkene one double bond and rest all the double bond will be single. In alkyne one triple bond, at least one triple bond, and rest all the bond between carbon and carbon will be single bond. So today I am going to tell you about the only alkane. First I am coming to this very important group of letters, alk. This alk is the root name of all the organic compounds. Root name. This is the root name, most important group of letter, the alk. Without knowing the value of alk, you can't write the name of any organic. In other words, I am saying to you that in all the aliphatic organic compounds you will find alk. In which form you will find alk, I am going to tell you. It means we have to know about the types of alk, what alk tells us. So alk. These types of the alk is, if there is carbon 1 in that organic compound, then the name of the alk will be meth. And if there are two carbons in the organic compound, then this is it. And in this way, I am not going to make the table of the arithmetic. So you will find in your book the C1 meth, C2 eth, C3 prop, C4 but, 5 pen, and so on, C10 dec. So these are the values of the. If number of carbon is in that compound is 1, then you will meth. So this is the value of alk. Now I am going to tell you about the alkanes. Rest I will take in my next video. So I am going to tell you today, if the nomenclature of aliphatic open chain alkanes. So if a alkane has a number of carbon atom 1, then the name of that alkane C for the molecular formula, of that hydrocarbon will be CH4, and the value of N is equal to 1. The number of hydrogen will be 2 into 1, 2 plus 2, so 4. If the number of carbon 4, then the molecular formula will be 10. So N is equal to 4, N is equal to 4, the number of hydrogen will be 10. So in this way, the name of this hydrocarbon will be methane, and the name of the hydrocarbon of C2H6 will be ethane, and C3H8 the name the propane, and C4H10 will be the name of butane. In the same way, you can write the molecular formula of all the alkanes. So here I have told you about how will you find the molecular formula of these alkanes. So this is the alk, and alk here ane, ene, ine. These are the suffix. When alk is suffixed with ane, the name of the compound will be alkane, and when the value of alk is meth, and it is suffixed by ane, then the name of the hydrocarbon methane. Suppose if I write the CS3, CS2, CS2, CS2 and CS3. See, all the carbons are combined with single bond, one thing for the alkane. And again, the carbon 1, 2, 3, 4 and 5. The name of the hydrocarbon, the molecular formula of the hydrocarbon C5H12, 3 to 5 to 7 to 9 plus 3 hydrogen, C5H12. In this way, you can decide the molecular formula of the alkane with the help of this general formula. If there are number of carbon atoms are 8, then the number of hydrogen will be 8 into 2, 16 plus 2, C8H18. This is the name of this hydrocarbon will be obtained. So here one thing. Second one, when in this alkane, suppose this is alkane, and you replace the one hydrogen from this alkane, so the rest part will be known as alkyl. Suppose alkyl. Again CnH2n plus 2, you will replace the one hydrogen atom, then the rest general formula of the alkyl will be 2n plus 1. One hydrogen is replaced, the number 2 here, the one is hydrogen replaced with then the rest will hydrogen CnH2n plus 1, and one place is here vacant for hydrogen. For any other group, one place. In this method, suppose I am taking the example CH4, and one hydrogen is replaced, then the rest part of the methane the rest part of the methane will be CS3. And this will be called as methyl. In the same way, here the suffix, the meth is suffixed by I. The meth with suffix will be I. So these are the terms that will be, decide to identify the name of the compound. These are these are called suffix. These suffix are the terms which decides the name of the hydrocarbon or the organic compound. So here, what is methyl? This is alkyl groups. So these are also called the radicals. These are the methyl. So meth plus I. In the same way, suppose this is C2S6. C2S6. So one hydrogen is replaced from this, then the rest part will be C2H5, and again one is here. It is known as, in the same way, number of carbon here 2, so the alk will be it, and here the general formula of this here, it means you will suffix it with the ether, and then it will be I, ethyl. Then it is ethyl. In the same way, this is C3H8 propane and C3H7 propyl. So propyl, and the same way butyl. So these are the alkyl groups. So alkyl, I think that you have understood the name of hydrocarbons, alkane, and what is the meaning of alkyl and alkane. So if I write to you suppose here I am writing this formula CH4, this will be methane, and the alkyl group of this methane will be CH3, and it is methyl. Again, C2S6, and the structure formula CS3 and CS3. When one hydrogen is replaced from this CS3, the CS3, CS2, ethyl. This is ethyl. This will be ethyl. CS3, CS2. One place is vacant for hydrogen or any other substrate group. So again, C3H8. C3H8. This is propane, and the alkyl group CS3, CH2 and CH3. See, this is propane, structure formula of the propane, CS3, CS2, CS3. So CS3, CH2 and CH2 here. So it is propyl. It is propyl. So here the vacant, the hydrogen is replaced from the first carbon, so it is called 1-propyl. So it is called propyl. So again, or it is N-propyl. It is also known as N-propyl. And again, you can replace one hydrogen from the middle carbon. Then this will be isopropyl. This will be isopropyl. This can be written in this form also. So the second CS3, CH and CH. This is isopropyl. So remember this structure of the isopropyl. It can be written in this way in the straight way, and this can be written in this way: CH3, CH3. It is isopropyl. So they are the alkyl groups of the alkanes. So here again, now I am coming to give you a question that write the name, the molecular formula of pentane. Suppose I say you that write the molecular formula of pentane. You will write the molecular formula C5H12. C5H12. This is the molecular formula of pentane. And now I say you that write this possible structure of the molecular formula of C5H12. Possible formulas, possible structure formulas. So first you will write CH3. Suppose you made a carbon, long chain of carbon. There are 5 carbons. All the 5 carbons are attached with the single bond. All the 5 carbons are attached with the single bond. And you know, all the carbon atom has 4 valency. So you should have fulfilled all the 4 valency of the carbon in this way. This is the skeleton of the structure formula of the pentane. So here you can write in this form CH3, CH2 and CH2, CH2, 1, 2, 3, 4, and this is 5. This is the structure of pentane. You can say the name, this is pentane. This is the name of this pentane. This is pentane. Again, there are 5 carbon atoms, and you have made you have written all the 5 carbons in a longer chain, in a form of a chain, straight chain. Now, suppose you can write the 5 carbon atoms in this way also. 1, 2, 3, 4 and 5. This is also a possible structure of the C5H12. 5 carbon maybe you can find the all 5 carbons in this way. This is also a 5C5. So it is a branched. So I am telling you, I gave you a term on the beginning, that unbranched or the longest change unbranched. So this is unbranched hydrocarbon, and this is the skeleton of a branched hydrocarbon, because this carbon has a branch with another carbon atom. So how will you recognize the branched or unbranched? This is unbranched hydrocarbon. Unbranched hydrocarbon. And this is the skeleton of branched hydrocarbon. This is the branched hydrocarbon. In branched hydrocarbon, you will find at least 1 carbon is attached with 3 carbon atoms. Minimum 3 carbon. Well, this carbon is attached 1 carbon, 2 and 3. So when a carbon attached with 3 carbon atoms in a chain, that is branched. And when only the 2 carbon, in this way, when the carbon atoms are attached only with 2 carbon, adjacent 2 carbon atoms, this carbon is attached with 2, this will also 2, but here this carbon is attached with 2, this carbon is attached 2, this carbon is attached 2, but this carbon is attached 1, 2, 3 carbons. So it is a branched This can also be, see, you can write this 5 carbon in this way, in this way. These are the, again trans, this carbon is attached with 4 carbons, so it is a branched hydrocarbon. So I think that you have understood the difference between the branched, unbranched and branched carbon. So when a chain has 1 carbon attached with the 3 or 4 carbon atoms, that the hydrocarbon will be branched hydrocarbon. Otherwise, if all the carbons are attached with the 2 carbons or 1 carbons, less than 2 or 1 carbon, then they will be, the hydrocarbon will be called as unbranched hydrocarbon. So again, fill up the all valency of these hydrocarbon CS3, 2, and here only 1 H. Here again 3 hydrogen. So the condensed formula of this will be CS3, CH2, CH, CS3, CH3. CH, CS3, CS2, CS3, CS3. CS3, CS2, CS3, CS3. Again, the all you will write in this way: CS3, 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 CS3. So these are the 2 compounds here. The possible structure of the C5 or the C5S12 are 3 possible structure. C5, the molecular formula C5S12, the possible structure of this molecular formula C5S12 are 3. One is it, 1, 2 and 3. 1, 2 and 3. So the name of this hydrocarbon will be pentane. Will be pentane. And the name of this hydrocarbon will be methyl butane, methyl butane. And name of the hydrocarbon will be 2,2-dimethyl propane. So here the number, the name of the carbon atom, the name has changed. Here it is methyl butane. Here it is dimethyl propane. This you will find here L. You will find here L. All the organic compounds, or the aliphatic organic compounds, has the value of L, and that will be but, pro, or pent, pent, one thing. And when it is suffixed by ane, it means all the hydrogen structure will have this, are attached with, are combined with the single bond, so it is propane. Now this is methyl and this is methyl. These 2 group, this alkyl group is attached with this carbon. These 2 group are attached with the carbon, so it is methyl. So it is methyl butane. One carbon is inside branch, and that is in the form of alkyl group. It is known as methyl butane. And in the same way, this is dimethyl propane. Now, one thing you have noted, that the name are going to change. What what is the basic concept in selecting the name that this is a butane, this is a propane, this is a pentane? How will you decide? How will you decide this, that this is the propane and this is butane, this is pentane? Now comes to the most important IUPAC rule, the selection of the longest chain. Always the name of the hydrocarbon will be selected according to the longest chain or in the hydrocarbon, found in the hydrocarbon. So here the longest chain has 1, 2, 3, 4 and 5. In the chain, all the carbon atoms are in a sequence and there are 5 carbons in the chain. So it is pentane. Here you find the longest chain of 1, 2, 3 and 4. 4 carbon atoms. There are 4 carbon atoms. So the name, the root name of the value of alk will be but. The root name of the alkyl, this hydrocarbon will be but. So here 1, 2, 3, 4. And in this way you will find that there are 3 carbons in this, either this way or this way. Either this way, this is also 3 carbon and here also 3 carbon. So the root name will be prop. The root name will be prop and all the bonds are single, then propane, and here 2 methyl groups are in the shape of branching. So here again you will say that dimethyl, 1 methyl and 2 methyl. The name here dimethyl means 2 carbon. Again I am telling you the number of carbon are 5. Dimethyl meth has 1 meth has 1 carbon. Dimeth has 2 carbon. And here prop this 3 carbon. So all the 5 carbons are here. All the 5. And in this same way, meth has 1 carbon and but has 4 carbon. So you will find 5 carbon in this butane. This name tells us the total number of carbon atoms found in this hydrocarbon. So here meth has 1 carbon. Meth means 1 carbon. But means 4 carbon. So total 5 carbon. Here dimeth, it means meth has 1 carbon. So dimeth means 2. It means 2 carbon atoms. And prop tells us the 3 carbon atoms. So total number of the carbon atom will be C5 and all the hydrocarbons have the 5 carbon atoms. So all the carbon atoms, the 12 number of the hydrogen atom. So in this way we need the first law that is very important to decide the name of the hydrocarbon, that is selection of the longest chain found in the carbon. Second one, these alkyls, these alkyl or the methyl groups are called the substituent group of the hydrocarbon. So second one will be the locate. So in my next video I will tell you the selection of the longest chain hydrocarbon and to the location of the alkyl, the alkyl or the methyl or the substituent group. So today I hope that you have understood the basic knowledge of the IUPAC, that how will you decide the name of a hydrocarbon. Now we need the rules of IUPAC. There are so many rules. The first important rules is the selection of the longest hydrocarbon, and second one to decide the location of the substituent group. These 2 rules I will tell you in my coming video. Thank you for watching, and I hope that you have understood about the nomenclature, the basic knowledge of the nomenclature. So thank you very much.